There's obvious reasons why we would want to search for other planets. As much as we hate to admit it, our own planet isn't doing so great right now, and so it might not be a bad idea to start looking for alternatives. Welcome to Fact Nominal, and we're dishing out the details on some recent celestial breakthroughs in new Earth-like planets that have been recently discovered by the Kepler telescope. Fortunately, it seems NASA once also believed in the potential coolness of searching for new planets, and so they launched up a telescope to seek them out. That telescope was named the Kepler Space Telescope, and today we'll tell you about the crazy discoveries it made on its mission. Why the name? The naming convention for this behemoth is quite fitting. Johann Kepler was a famous astronomer that made incredible discoveries that shaped the way astronomy is studied today. His revolutionary 3 laws of planetary motion are used today in analyzing the orbits and movement of planets around other orbital objects. It only seems fitting that a telescope dedicated to analyzing other planets would be named after him. The design of the telescope. The main instrument of the Kepler telescope is a photometer, a device that allows for accurate measurements of the luminosities of various different objects. The photometer was designed specifically to continually measure the brightness of around 150,000 main sequence stars around the Milky Way. These are the most common form of stars and are the kind we'd need our future home to be orbiting around if we hope to not only stay alive, but thrive. This data would constantly be sent back to Earth, where NASA would analyze it to determine if any exoplanets had passed by the star. What's the mission? The Kepler Space Telescope had one seemingly simple goal: to go where no man has gone before and seek out new worlds similar to our own. The satellite was launched on March 7, 2009, in a heliocentric orbit that would give it a clear view of any Earth-like planets close to us. On October 30, 2018, the fuel for the telescope's reaction control system was officially deemed to be depleted, and NASA formally retired the telescope from action. That leaves a whole 9 years orbiting around the blue marble. What kind of stuff did it find during that time? What did it find? Over the course of 9.5 years of service, the Kepler telescope reported the observations of over 530,000 stars and successfully detected 2,662 planets. As early as 2009, the year it first came online, it had already reported some extraordinary results. In fact, within the first 6 weeks, Kepler had discovered 5 previously unknown planets, all of which were close to their associated stars. One of the results, as it turned out, was one of the least dense planets yet found. While it's not a viable candidate for Earth 2.0, it is interesting within the scientific community. By 2010, Kepler had reported data on all but 400 of the 150,000 target stars. Out of these, 706 were reported to have viable exoplanet candidates, with sizes going from the size of Earth to much larger than Jupiter. It took over a year for NASA to properly analyze the results of Kepler's finding, and on February 2nd, 2011, they made some groundbreaking announcements. Out of the potential candidates, the Kepler team noted 1,235 that were a size close enough to Earth that potential habitation could be considered. 54 of these finds were reported to be possibly within the habitable zone, the distance from a star at which a planet could theoretically contain liquid water. Obviously, if we're picking a new home, having some water on the surface would be one of our first priorities. It's possible that we may even have some roommates, unwanted or not. This discovery was quite monumental. Up until the Kepler team had reported these findings, only 2 planets were thought to be in the habitable zone. One of the more notable milestones was the discovery of the first exoplanets that resembled our Earth. 2 planets dubbed Kepler-20e and Kepler-20f. These 2 planets orbited Kepler-20, a star that was also quite similar to our own Sun. Based on these findings, astronomers made some estimates as to how many habitable planets we may have in our vicinity. Seth Shostak in 2011 estimated that within 1,000 light-years of Earth, there are at least 30,000 habitable planets. Adding to this incredible projection, the Kepler team used their findings to deduce that there are at least 50 billion planets in the Milky Way, with at least 500 million of them existing within the oh-so-sought-after habitable zone. What kind of planets did it find that were similar to Earth? Kepler 69c. Given that there's a reported 500 million planets in the Milky Way that may exist within our habitable zone, one would only expect that we'd find some that are similar to our own. A notable Earth-like planet popped up in 2013, Kepler 69c. Many studies have come to a similar conclusion that this exoplanet may be one of the most Earth-like planets ever found. Its size and temperature are remarkably close to our own, and it orbits its star at 0.7 AU, which means it's well within the habitable zone. That being said, while Kepler 69c may be habitable, it is by no means hospitable. Recent studies have found that the makeup of the exoplanet is more similar to Venus than it is of Earth. It wouldn't have any oceans, as the reported stellar flux of 1.35 would make sure that any water would be boiled away, and that's even at the lower end of the temperature estimates. As the oceans boiled away, water vapor accumulates within the atmosphere. Water vapors act as a powerful greenhouse gas, raising the surface temperature of the planet to an insanely high amount, about 227 degrees Celsius. This cycle causes a runaway greenhouse effect on the planet's surface. Given that most scientific estimates predict that Kepler 69c was, at one point in its life cycle, an ocean planet, the effect of this boiling would be devastating for the habitability of the planet. Low amounts of carbon dioxide would have been present in the atmosphere. And so, while Kepler 69c may look and have the same properties as our blue marble, it differs in small but impactful ways. If we were to eventually move there, however, the road trip would be quite long. It's located about 2,433 light-years away from Earth. Nevertheless, it's an incredibly interesting case study, and it definitely is something that science should keep its eye on in the future. Kepler 62e. Kepler 62e is another Earth-like planet that holds the potential to be habitable. Given the planet's age of around 7 billion years, a stellar flux of around 1.2 times that of Earth, and a radius of around 1.61 times that of Earth, it's entirely possible that Kepler 62e could possess a rocky composition that could even feature a large amount of water. In fact, studies into planets similar in size to Kepler 62e suggest that planets like it can be completely covered in oceans. So, yeah, it's well within the habitable zone. That being said, other studies have shown that planets with a radius of over 1.6 times that of Earth's run the risk of having a volatile, rich composition that is similar to Neptune's, meaning that our dream planet may, in fact, be completely gaseous, with no definite surface, and so may not be habitable for any terrestrial life form. Additionally, while the stellar flux of Kepler 62e is not that much higher than Earth's, it's entirely possible that the surface temperature could be over 77 degrees Celsius, which, unfortunately, is enough to trigger the runaway greenhouse effect that led to the demise of Kepler 69c. Regardless, the discovery of Kepler 62e led to a massive cultural appreciation for the efforts of the Kepler telescope. On May 9, 2013, a congressional hearing by two of the U.S. House of Representatives subcommittees discussed exoplanet discoveries. Have we found other Earths? Where the discoveries of Kepler took center stage, particularly Kepler 69c and 62e. Unfortunately, with 62e's distance of over 1,200 light-years away, it's just too remote and too far away for any of our current telescopes to get a good look at, and scientific instruments are currently unable to get accurate readings.